Hi everyone, welcome you all for this demo session for the experiment double shear test of metallic materials. So the aim of the study or the experiment is to determine the ultimate shear stress of the material. So by performing a double shear test, and we have two different types of machines are available with us. So one is the 200 kilonewton machine and the other one is a 400 kilonewton machine, so which has a different loading conditions or ranges of load as 40 kilonewton, 100 kilonewton, 200 and 400, as in the case of 400 kilonewton capacity machine. The same way we have 20 kilonewton, 50, 100 and 200 as in the range of 200 kilonewton capacity machine. And this is what our observation table. So we'll be noting down the ultimate load value, that is the maximum load at which the material fails, and the corresponding shear stress or strength of the material. And with respect to the specimen, we have two different types of our cross section. One is of 8 mm cross section and the other one is of 12 mm, and the corresponding variation or the load range as were given here with respect to the two machine. For 400 kilonewton we have say for example 8 mm specimen, we have a load range of 0 to 100 kilonewton, and for a 12 mm specimen we have to set the load range as 0 to 200 kilonewton and so on. And different types of material can be tested. One is of mild steel and aluminum, and the corresponding load ranges for aluminum is also being given. And we'll with respect to the specimen, here we have two different types of specimen as I mentioned below earlier. One is 8 mm dia and the other one is of 12 mm dia, and two specimens were given, and we'll be able to measure what would be the ultimate shear stress of a material by performing a double shear test. And in order to fix the specimen into the machine, we do have a separate fixture where a compressive load can be converted into a shear load. So in the actual scenario, we'll be applying a compressive load with respect to the machine, and by making use of this fixture, we'll be able to convert that compressive load into a shear load. And there will be a two sort of on two sides the corresponding shear stress would be applied, and the corresponding area of cross section at which the shear load will be subjected to. So this is one side, and the other side on this face. So when this compressive load being applied, in that case there are two shear forces that would be generated on either side of the fixture, and that would induce the corresponding shear stress, and that is why this particular experiment is called as a double shear test. Okay. And with respect to the different specimen, we do have different bushes available in order to hold the specimen rigidly. As I mentioned earlier, we have got two different specimens of 8 mm dia and 12 mm dia, and we have got three different bushes which could accommodate the respective specimen into the fixture. Okay. So with respect to the fixation of the specimen into the fixture, here we have three different types of bushes as I've indicated, and this is what our center block, which could guide the entire rod or the material into a fixture. And we are supposed to hold the center bush first of all. Okay, say for example I have taken up a 8 mm dia rod, and the corresponding specimen size is 8 mm, and the respective bush, if you have any sort of confusion, it is imprinted on the bush as 8 mm and 12 mm. So that way you can ensure that what type of cross section you are looking into. And just place the respective center bush first onto the fixture, and then place one other end of the bush, and then guide the specimen into the fixture. so that on the other side the specimen would started to guide with respect to the bush and place the other end of the bush also. So this is with respect to the fixation of the specimen onto the fixture. Center edging test. We have this universal testing machine in order to perform the double shear test also. So only difference, as I mentioned earlier, we will be applying a compressive load, and because of the fixture what we have provided, so the compressive load has been converted into a shear load, and shear load is applied on either side of the specimen, so we used to call this as a double shear. And with respect to the operation, so we have seen a few of the procedure while we are performing the tensile test. The procedure are merely same. Here we have two different needles. One is of blue one and the other one is of red one. So red needle will started to guide the blue one, and once it reaches the ultimate load, so the maximum load at which the specimen breaks, so once it reaches the maximum load, red needle would stop at that position and blue needle will started to retract back. When it is getting retracted back, so failure will occur at a certain point. Okay, so in order to make us easily note the maximum stress at which the material fail, we have this red needle. And very similar to the tensile test, here also, as I have indicated from the tabular column, so for different capacity of the machine. So as in this case, this particular machine has a capacity of maximum of 400 kilonewton, and in that case we will be able to change the ranges of load with the knob provided over there, which can vary from 0 to 100 kilonewton, 40 kilonewton and 200 kilonewton. Different ranges are there, and based on the respective material what we are going to test, accordingly we can set the load range. As of now, the total range of load that has been set onto the machine is 0 to 100 kilonewton, and each division will have a least count of 0.2 kilonewton per division. And here basically we have two different walls. In order to move the cross head, so the two pillars or the screw rod, whichever is shown over there, we used to address it as a cross head, and this cross head travel can be controlled by making use of these two switches in order to have an upward motion and as well as the downward motion of the machine, so which could guide along the cross head. And in order to apply the gradual load, once the particular specimen or the cross head has been moved with respect to the height of the specimen, and then gradual load can be provided by making use of this hydraulic pump. And for switching on the hydraulic pump and switching off the hydraulic pump, here we have two different switches as on and off button. Okay, and now we have fixed the specimen onto the fixture, and now just place the corresponding fixture onto the base of the machine, and then just move the cross head and align it with respect to the fixture's top end. So with your naked eye, ensure the minimal gap between the top base of the machine and the top of the fixture. And once it is done, ensure both the valves are in the closed condition and switch on the hydraulic pump. Once the hydraulic pump is switched on, open the right lever into the anti-clockwise direction. gradually. And from the dial, you'll be able to see whether the load is being applied or not. So needle started to deflect. Both the blue needle and red needle is started to deflect. And now the actual compressive load is applied onto the specimen. Because of the fixture, the compressive load is converted into a shear. Now the maximum limit is arrived, so that is why the blue needle started to retract back and the failure of the specimen occurred. Once the material got failed, the blue needle will go back to the initial condition, and the red needle has stopped at a certain point. So that is the maximum limit at which the material resists the corresponding load. So which used to address it as an ultimate load, which defines the strength of a material. And since the respective type of load we have applied is of shear, we are addressing it as an ultimate shear stress. The red needle now reads the maximum load as 42 kilonewton. So just have a note on the ultimate load of the specimen from the red needle. As we have discussed earlier, our ultimate aim is to measure the ultimate shear strength of the material. So the material whatever we have used is of mild steel. So ultimate shear strength of the mild steel material. And this is the formula we are going to make use of in order to determine the ultimate shear strength. That is, ultimate shear stress is equal to ultimate load divided by 2 times the cross-sectional area of the specimen. And as we know, like stress is force upon area, and since the force is applied on either side of the cross-section, so that is why the term 2 is included at the base or the denominator. That is 2 times the cross-sectional area of the specimen. So force or load divided by 2 times the cross-sectional area will give us the ultimate shear strength of the material. So we have noted down the maximum ultimate load as 42 kilonewton. So 42 kilonewton divided by 2 times the cross-sectional area of the specimen. So the area of the specimen, we have made use of 8 mm rod. So pi by 4 d square, pi by 4 8 square will give us the cross-sectional area. So 2 into the cross-sectional area on the denominator, so which will give us the ultimate shear strength of the material. Thanks for listening.